Okay, so I'm not going to talk about my PhD, but I'm sure I'm working on my PhD. It's more of a side project, and I'm going to talk about bats in Colombia, also bats in Colombia. So the Colombian Riversleigh is called La Venta. It's smushed in between two Andean mountain ranges. It's located in the Tatacoa Desert, and around 150 different vertebrate species have been described on this side, and just about 70 mammals, I think. Some of the species that have been described, like we had our version of the Thylacine, a completely different lineage of my carnivorous marsupials. We had things similar to elephants and our own kind of like people, like native South American mammals. The La Venta is really important because it's the richest primate assemblage in South America, and it's the richest bat assemblage in the Neotropics, and as you said, the bat fossil record is like really poor. So this site is particularly relevant. Within the bat assemblage, so far we know of around 14 species. And La Venta is crucial for defining the La Ventan. The La Ventan is part of what's called the salmas, which is basically like temporal units that we use to describe the temporal frame. And instead of going like year by year, you just like make chunks of it so that you sort of smooth the curves. And Colombia, the La Ventan is only described by this side. And this side is particularly relevant because all the salmas that have been described in South America, La Venta is the only one that's from the Neotropics. All the rest are coming from Argentina, Chile, Brazil, and Peru. So we've known about La Venta for about 100 years. With this guy, an American Christian priest or something, that for some reason was importing poisonous potatoes into the US in the 1920s. And apparently he was also doing paleontology. Then in the 1940s, Jose Arroyo Gomez, which was like a Spanish refugee fleeing the dictatorship in Spain, he ended up founding the Colombian Geological Service and the Geological Museum. And Ruben Steerton from the University of California, he was one of the first ones to formally describe most of the species that we know so far. Then in the 1980s, it was like the largest and the latest big effort to do research, and it was mainly three people: Richard Kay from Duke University, Masanaru Takai from Kyoto University, and Nick Sapleski, which is now in Florida. So it took us about 100 years to notice a pattern, and it's that there are no Colombians doing paleontology in Colombia. So now, to sort of address that, we're starting a new effort to do research in La Venta, especially. There's a bit of discussion because some people want it to be Colombian only, while other people want to involve other people. I would be a bit hypocritical to be Colombian only, considering that I've been living off your taxes for 2 years. So I'm up for it, including some people from overseas. And I'm gonna focus in this species, Notonipteris magdalenensis, and it's one of the oldest known Philostomide fossil bats. Now, Philostomide is a really interesting bat family. As Sue mentioned before, there were like two different lineages of bats that adapted to fruit eating and like plant visiting. This is the neotropical one, and this family is particularly interesting. And this species is particularly relevant because the only two known fossils from this family come from La Venta. Now, previous studies have suggested that the other species was adapted to be an nectarivorous, but it was actually an omnivorous. So this is really interesting because modern philostomids range in diet, sizes, and shapes that you can't even imagine. Like you have the vampire bats, you have nectarivorous bats, you have frugivorous, you have insectivorous, you have animalivorous, so you have a bit of everything just within one family. So we wanted to see if we could sort of infer the diet of Notonipteris magdalenensis based on dental complexity. So we used 3 different measures. Like this one is just basically testing changes in the curvature of the surface of the tooth. This one is basically a ratio between the 3D area and the 2D area of the tooth. And this one is basically looking at the orientation of the faces of the surface of the teeth, and that's going to give you an idea of how complex it is. So based in that, we analyzed 2 lower molars from this species, and we compared them with 19 modern species of the same family. This is just only to show that not a single variable is able to separate clearly the diets. Like you can see that the species that have liquid diets for nectarivorous and sangivorous tend to have like a lower dental complexity, which makes sense because they basically need their teeth. But it's actually the combination of all the 3 variables that gives us an idea of what these species could have eaten. This is to show that there is a relationship between 2 of the variables, but the 3rd one, the values are not correlated with the others. And basically, with what we have so far, we can sort of suggest that the combination of the 3 variables can pretty much separate all the different diets. We have the frugivores here, the liquid diets here, and there's a bit of an overlap between omnivores and insectivores, which makes sense because within this family, omnivores range from like frugivorous species that eat insects to animalivorous species that eat fruits. So there's a big variation there, and as we can see, our fossils fall within the omnivorous, insectivorous sort of range. So basically with this, we can suggest that Noctonicletis magdalenensis was an omnivore, which suggests that combining with the previous result of the other species from La Venta, this community was probably very generalistic. And now we would like to analyze the entire fossil assemblage from La Venta. Okay.
So there's been a big debate about how vampires evolved and about whether they were closer to nectar-feeding bats and went through that stage, or whether they were probably omnivores that were actually presenting any insights on this, or were they just too extreme to relate to other nectar-feeding bats?
I guess with this family it would be hard to make that correlation because as far as I know, even nectarivory is not monophyletic with phalanstomies, so nectarivory actually evolved a couple of times. So it would be interesting to look at some of the fossil vampire bats and try to fit it in the analysis doing some phylogenetic reconstructions. I would say that it's a completely different event, but I wouldn't dare to say.
Thank you, Camilo.